Right now, I'm excited to bring to the stage Dr. Stuart Cowan. He's the executive director of the Buckminster Fuller Institute, and included in a very long list of his experience and skills is that he is a systems thinker. He's a transition designer. He's co-founder of a company called Autopoiesis LLC, which I'm sure he'll talk to us about. And he's working on regenerative communities, ecosystems, and organizations. Welcome to the stage, Dr. Cowan.
Hi, Ken. Great to be here.
Hey, nice to see you again. So, you probably know as much about Bucky as most people do, since you run his institute, and there's so much material to go at here. But let's start with his overarching view that he had a vision. He had a vision for the future of a world that works for everybody, right, and without any negative impact on the environment or any disadvantage to anybody anywhere. And he did that by virtue of this thing he called design science. Let's talk a little bit about what design science was to Bucky.
Wonderful. And we should remember that Buckminster Fuller lived this extraordinary life that spanned 1895 to 1983, a time of unbelievable transformation. And from a fairly young age, he was a world famous figure and traveled everywhere, constantly inspired young people, spoke to diplomats, spoke to CEOs, tried to inspire people wherever he went with a vision of a world that could work for all of humanity and really all of life, and to do that through what he called spontaneous cooperation. And underpinning this all, as you're saying, Ken, is design science. And to really unpack it, the phrase he often used was comprehensive, anticipatory design science. Comprehensive meaning that you have to look at every conceivable dimension of a situation. So keep expanding the focus, make sure you're thinking about every conceivable influence on that situation. Anticipatory, looking ahead 10, 20, 50 years, looking ahead many generations if needed. Being really tough, saying, wait a minute, this amazing design approach seems to have a lot of benefits, but does it have some drawbacks? Does it create confusion and complexity somewhere else in the system? So we have to anticipate things that might unfold as a result of this design intervention. And then, of course, centering design thinking and design in a very broad sense, a multidisciplinary, multi-scale approach to design. And finally, grounded in rigorous science and what we would now call systems thinking. So a word like synergy became a doorway to infinite design potential. Synergy existed as a term, but hadn't really been used precisely in the sense of a whole system behaving differently than the individual parts, in a sense unpredictable from the parts separately. And he often used the example of metallic alloys, where you could take 2 or 3 different metals, combine them in just the right way, just the right alloy, and actually get superior strength, superior properties, unpredicted from the materials separately. Like they would actually perform better in combination. And that's the core concept of Fuller's design and thinking, that you put things together in the right way. There are cascading benefits, as he would say. So all of these amazing co-benefits, cascading benefits, ripple through the system, and you're ready for the next intervention and the next intervention. And all of this designed with life. So essentially biomimicry. Of course, he didn't use the term. Janine Benyus popularized that in the 1990s. But really, it was biomimicry thinking. It was whole systems thinking. And Ken, it really was circularity. It was circular economics thinking as well. So another key term for Fuller with this very precise vocabulary was ephemeralization. Think ephemeral, right? Beautiful word. So something that's fleeting. So he turned that into a design concept. Ephemeralization is that process of doing more and more really useful, important things that meet real needs with less and less energy, material flow through, and specifically less and less, quote, waste. So it
Right.
really was a circular concept. So if you could use the material in a completely recyclable way, or obviously thermodynamically, there might be slight limitations, but if you could use
Well,
something
thank
over
goodness we have the sun.
right, right. But if you could use something over and over again, that would be part of
Yeah.
ephemeralization. If you could do design for disassembly, that would be part of ephemeralization. So it really was this concept of meeting needs with minimum entropy, minimum actual waste in the system.